Hey everybody, let's have a look at the quiz for week one. Making these quiz videos is always a little bit scary for me because I'm doing math problems live in front of you. I wrote the math problems, but still I make mistakes sometimes. So if you do catch any mistakes, please let me know so that I can post a fix. Okay, I got my calculator ready. Let's see. Convert this angle to radians. So we'll take this angle, 25.14 degrees, and to get it to radians, we need to multiply by 1, but we need to write 1 as a ratio with different units so that we can get rid of the degree units and produce radians like this. Then we need to put angles in here that are the same angle so that this fraction right here is equal to 1. And pi radians is equal to 180 degrees. Okay, so that's going to get rid of the degree unit and produce radian units like we wanted. So we're going to take 25.14, multiply by pi. My calculator has a pi button built in. And then divide by 180, and we get 0.43877 radians. Okay, radian angle measure for this angle. So we know the arc length here, that's S, and the radius, right, the radius is 3 inches here. So this radius is 3 inches, that's R. So the angle measure is the arc length divided by the radius. So 5.835 inches divided by 3 inches. The inches cancel. Let's see, 5.835 divided by 3, 1.945. And we could leave this with no units, but when we measure angles this way, we typically write radians here. Although we do have to keep in mind that this radian unit isn't actually a unit. It can disappear if we measure, if we use an angle in a computation that produces a different kind of measurement. We've seen that happen before. Okay, number 3, find these quantities. So sine of 13 pi over 4. So 13 pi over 4, let's see, 13 pi over 4. We need to understand like how big this is compared to 2 pi, right? So this is, let's see, 2 pi is 8 pi over 4. So this is 8 pi over 4 plus another 5 pi over 4. So 8 pi over 4 is a full turn, so that's like this, and then another 5 pi over 4 is like that, right? So this is coterminal, or sorry, this has a reference angle of pi over 4. So this angle right here is pi over 4. That's the reference angle. Remember, reference angles are always measured to the x-axis. So sine of 13 pi over 4 is the same as sine of the reference angle, so that's pi over 4, but possibly with a minus sign. So now we have to think, in this quadrant, is sine going to produce a positive value or a negative value? It's negative because sine is a y-coordinate in this picture, and this y-coordinate right here is negative. So we need a minus sign here. And then sine of pi over 4, that's one of the common values. That's root 2 over 2. Okay. All right, so how about tangent of minus 4 pi over 3? So minus 4 pi over 3, that's minus pi minus another pi over 3. So that's going to be something like this angle. Okay, so the reference angle here, again, measured to the positive x-axis, is pi over 3. So tangent of minus 4 pi over 3 is the same as tangent of pi over 3, possibly with a negative. So now we have to ask ourselves, in this quadrant, is tangent negative or positive? And remember, tangent tells you about the slope of the terminal side. So we have to ask ourselves, is the slope of this terminal side here positive or negative? Well, it's negative because it's going down, so we do need a minus sign here. Okay, so minus tangent pi over 3, and you might remember that one. That's square root of 3. If you don't remember the tangent of pi over 3, though, you could write tangent as sine over cosine. So this will be sine of pi over 3 over cosine of pi over 3. So that's negative. Sine of pi over 3 is root 3 over 2. That's one that you should know. And cosine pi over 3, that's another one you should know. That's 1/2. And then you can simplify this fraction by multiplying the numerator and denominator by 2. But then that simplifies down to minus root 3. Okay, number 4. So we have this satellite that measures parallax angles. I don't think this satellite is actually in operation anymore. Maybe I should update this problem. So measures parallax angles to thousands of stars. So for one star, we measured this angle. This tiny angle here is 1.33 times 10 to the negative 5th degrees. The distance from the Earth to the Sun is this giant distance. Find the distance from the Sun to the star. Okay, so let's see. Let's call this horizontal distance x and this distance y. And the Earth to the Sun, 9.29 times 10 to the 7th miles, that's y. That's this distance here. So this is 9.29 times 10 to the 7th miles. Okay, so, and we want to know x. We want to find x. And we know y. So we should use a trig function that relates x and y. So that's going to be the adjacent side and the opposite side. So that's tangent. We should use tangent. So tangent of that angle theta, which is this angle up here, is y over x. So tangent of the angle, which is 1.33 times 10 to the negative 5th, is equal to 9.29 times 10 to the 7th miles divided by x. And then do some algebra to solve this for x. We're going to get x equals 9.29 times 10 to the 7th miles over tangent of 1.33 times 10 to the minus 5th, and then I didn't write, it should say degrees right here. So this is degrees. Okay, so when we punch this into our calculator, we have to make sure that our calculator is in degree mode. Right now mine is in radian mode, so let me switch to degree mode. Okay, now I'm in degree mode, so 9.29 times calculator problem, start over. 9.29 times 10 to the 7th divided by tangent of 1.33 times 10 to the negative 5th. Okay, and I get 4.00208 and more times 10 to the 14th. And let's see, for units, let's see, the number coming out of tangent doesn't have any units. So this mile unit here survives. So this is in miles. So 4.002 times 10 to the 14th miles. Let me just double check that. So 9.29 times 10 to the 7th divided by tangent of 1.33 times 10 to the 14, no, I'm looking at the wrong place on the screen, times 10 to the minus 5th. I hope I have the right number of parentheses in here. Okay, yeah, that gives me the same thing. So this 4.002 times 10 to the 14th is right. Which, I mean, that's an awfully long way, but, you know, it's a long way to other stars. So it seems plausible, I guess.